a real claim to fame is corrosion under the insulation. So scanning for hidden corrosion under insulated piping. The robotic solution will crawl down the pipe and then automatically raster around and go back the other direction. And that allows the asset owner to then get is a 100% inspection over this length of pipe that is displayed then in a 3D digital representation with an exact location of areas of concern.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 443. Can ground robots solve the toughest challenges in industrial inspections? For that answer, we head to Houston, Texas, to speak with Craig Malloy, CEO of Arix Technologies. Arix Technologies specializes in robotic solutions for inspecting corrosion under insulation, or CUI, in industrial piping systems. While we often focus on aerial drones in this podcast, some environments call for a different approach. That's where Arix's flagship product, the Venus robotic crawler, comes in. Designed to traverse both horizontal and vertical pipes, it collects high-resolution data without removing insulation or erecting scaffolding, dramatically reducing inspection times, cost, and risk. The technology has earned the trust of industry giants like Shell, ExxonMobil, and Chevron, proving its value in the field. Craig is a seasoned CEO with over 25 years of experience founding and scaling global tech companies, including ViaVideo, Lifesize, and Bloomfire. A pioneer in video conferencing, he led Lifesize transformation into a global software-as-a-service platform with 4K video and contact center solutions. Known for his customer-first mindset and servant leadership, Craig brings a unique blend of innovation, integrity, and vision to the world of robotics and industrial inspection. In this episode of the Drone Radio Show, Craig talks about Arix Technologies, the robotic system used to detect corrosion under insulation, and how it benefits the energy industry. But before we hear from Craig, I want to stress that your support is the heartbeat of my podcast. Every episode is crafted with you in mind, and your generous donations ensure I can keep delivering the content you love. Whether it's a price of a coffee or a more substantial contribution, every bit helps to defray the cost of production. Donate today and be a vital part of the podcast. To donate, go to droneradioshow.com/donate. And if you can, please subscribe to the podcast on your favorite platform and leave a nice review. It really helps improve the podcast ranking among the many thousands of active podcasts today. And by the way, if you have a great story on the use of drones that you'd like to share in a podcast, contact me at randy@droneradioshow.com. So let's learn how robotic technology can solve some of the toughest challenges in industrial inspections with Craig Malloy of Arix Technologies. Let's pick up the interview where I asked Craig to introduce himself.
My name is Craig Malloy. I'm the Chief Executive Officer of Arix Technologies, located in Houston, Texas.
Craig, let's start with the basics. What does the company do?
Well, at Arix, we're reimagining the workflow of inspection for corrosion under insulation, or CUI, for piping systems for asset owners, primarily in oil and gas refineries, petrochemical refineries, and some power generation plants. CUI, or corrosion under insulation, is one of the most intractable problems in the oil and gas business. Very, very difficult to find, and potentially catastrophic consequences in terms of environmental and safety concerns. And at Arix, we've developed a robotic solution that dramatically reduces risk and saves costs, while at the same time providing much more comprehensive inspections.
Can you explain what CUI is and where it typically occurs in industrial environments?
If you can imagine an oil refinery, most of them, any significant size oil refinery has thousands of miles of piping. Just kind of some of it very densely populated close together. Others is very, very long run, various sizes. The vast majority of that piping, and there are some, difference, but the vast majority of that piping is carbon steel pipe covered with some form of insulation, maybe an inch to two thick, or, kind of around the circumference of the pipe, and then covered with an aluminum jacket that's held in place by aluminum bands, kind of, locked in place. And the aluminum jacket isn't completely sealed, it's not completely watertight. So often, depending on whether a refinery is near the ocean or the refinery is in an area that has a very humid environment, or piping is in an area where it is large swings in temperature, freezing to very, very hot, either environmental moisture or just moisture from the temperature swings can cause the moisture to get into that insulation, saturate the insulation, and then you have soggy, wet insulation sitting on a metal pipe. And inevitably, that's going to cause corrosion and loss of wall thickness, pitting, and eventually a leak or some kind of a catastrophic problem and an explosion. Refineries have thousands of miles of this pipe with this setup, insulation and a jacket, and you have a bare metal pipe and you're walking along. It's like, oh, that's rusting. And I used to be a Navy officer on a big metal ship in the ocean, and that thing rusts. From the moment everything is starting to rust, and there was just a huge amount of maintenance of priming and painting and trying to counteract the rust. And the same things happen with this piping, and it's just hard to see. And so there's got to be, the kind of the foolproof way of doing it is stripping all the insulation and then visually inspecting it, or using ultrasound to measure the wall thickness. That's very, very time consuming and very, very expensive.
There are several companies that do oil and gas inspections. What makes Arix's approach different?
Well, the way that we do, and we specialize purely on inspecting piping, and really, and today our real claim to fame is corrosion under the insulation. So scanning for hidden corrosion under insulated piping. And what makes Arix special is the robotic solution that we've developed. It's if you look at our homepage of our website, we've got a nice video of what it looks like. It looks like a little exoskeleton that fits on top of the pipe. Some very specialized wheels, and it's our ninth generation and arms that hold on to the pipe. Our ninth generation robot. It's 8 years in development to get to the exact right clamping force and speed, and it provides for 100% inspection along a particular length of pipe. The robot will crawl down the pipe and then automatically raster around and go back the other direction. And all depending on the circumference of the pipe, we inspect piping from 4 inches to 18 inches. So an 18-inch pipe would take more passes than a 4-inch pipe. That allows the asset owner to then get is a 100% inspection over this length of pipe that is displayed then in a 3D digital representation with an exact location of areas of concern as measured by percentage of the wall thickness, and then they can go back and maybe strip the insulation around a 1-foot section rather than a 500-foot section. There's nothing in the market that does that today.
How big is the robotic unit?
Yeah, it's about 2.5 feet long and weighs just under 20 pounds. So it's very easily deployed by one person around a pipe, either at a chest level or even overhead or on a ladder or on some kind of a man lift, or it could even be deployed at height by a rope crew if the pipe is starting at 30 feet off the ground. We inspect horizontal pipe and also vertical pipes. A lot of these pipes in a refinery, we have a 100-foot tether, and we'll crawl up this vertical pipe segment 100 feet in the air, which is very, very difficult to inspect.
What type of pipes is it designed to inspect, both in terms of size and typical length?
Yeah, it can really vary. So we can handle pipes that are 4 inches. That's the complete outside diameter, including the insulation, to 18 inches. And so that's a pretty significant cross-section of the piping in a refinery. And then we can, sometimes the segments or the circuits, as they're called, are 30, 40 feet long. Sometimes the circuits are a mile long, like a dock line going from the refinery down to a ship. Sometimes they're over over marshes or swamps where a person can't get in there. So we can just, kind of run it over a road. It's just much, much easier for us to navigate this robot while getting, 100% inspection. And there is one caveat. We don't inspect around elbows, sharp right-hand turns. And so that small section would just get manually inspected and then also entered into the inspection portal so you get a full view. We can do obstacle avoidance. A lot of these long runs of piping that could be a mile long, for instance, would have pipe struts or supports, and the robot can do obstacle avoidance. It's not a completely around the pipe. There's some safety arms that we can lift and rotate the robot so we can get almost, kind of all the way up to the pipe supports. And then any little remaining section we can just get, with manual inspection, get it into the inspection report. So very comprehensive inspection.
Is obstacle avoidance fully automated on the robot, or does it require human oversight during inspections?
Today it's done manually. So the robot is operated with a two-person crew that are trained inspectors and also are trained on our robotic system. And the robot is mounted on the pipe, and there's a 100-foot umbilical cord, control signal up the robot, and then data back from the robot. But the driving of the robot is actually done with an industrial, it looks like a industrial strength Xbox controller that's designed for that task with a fail-safe stop button on it. And then there is an auto mode. We set the length that it automatically rasters around and sets the beginning location so you know exactly where you are. But the obstacle avoidance is done manually when we come up to a pipe strut. The safety arms open, the robot rotates, and then moves over, and then the safety arms go back around, and it moves on its way. Over time in the future, we'd like to continue to develop more and more full autonomy. That maybe sometime in the future, these inspection robots run a full shift on their own with no human intervention at all, continuously sending back real-time data for the piping. And we're just still at the very, very front end of this move to autonomy.
You chose a ground-based robot for the inspections, while many others are turning to aerial drones. What specific challenges led you in that direction?
Well, I think it is the 100% inspection and the very narrow profile on it. For instance, if you have a pipe rack where you have many, many pipes that are kind of right adjacent to each other, and they could be even stacked up, like layer cake. Our robot only needs about 3 inches of clearance, to completely rotate around. These pipe racks can be fairly dense, even for humans, to get in there and work all day doing manual inspection. And it would be almost impossible for a drone to get in there. The 100% inspection all the way around, upside down on the bottom of the pipe, kind of lends itself better to the form factor. Obviously, drones have many, many amazing use cases that have, revolutionized large swaths of the workflows around inspections. Like an aerial drone doesn't solve everything, just like our robot doesn't solve every workflow.
You touched on the complexity of the environments, like the pipe racks. How does the robot navigate those tight and cluttered spaces while still collecting accurate data?
It's visually driven. I mean, it's visually controlled. So we need to have eyes on it. We don't just let it go. So a person, one of our operators, sets the robot on the pipe. It automatically marks the exact position where they are. And we do a, kind of a visual inspection of the area where we're going to inspect. We know where we're going to need to engage the obstacle avoidance. We know where we might need to flip the robot around to get up, right up to the obstacle. Just like any other job site, we need to make sure we know what the workflow is going to look like there. The robot is set. It takes 30 seconds to set the robot on the pipe or less. And then we start driving, and we can real-time monitor the data, and then it's also collected and uploaded to the cloud later from the inspection portal. So all visually driven, very low clearance that's needed between those pipe racks and supports, and the robot's very light, very, very safe, and no chance of coming off the pipe in terms of safety.
What technology does Arix use to detect CUI through the layers of insulation?
There's 2 primary methodologies to find corrosion under insulation, and we did not invent these methodologies. Have been around for many, many years. What we've done is optimize the use of those inspection methodologies. The one that's on our current version of robot is called PEC, or pulse eddy current, and that's a scanning methodology that gives you a relative thickness of the piping wall to a reference range, and percent that, well, there's 80% wall thickness here, there's 75% wall thickness here. It's basically a coil with an electric current, a probe that's made by a third-party company that we mount on our robot. It's a coil, electric current is run through it, that creates a magnetic field that's sent down through the insulation And when you turn off that electric current, it creates this eddy current. And then depending on the return signal from that eddy current, it helps identify, what that wall thickness is in terms of the return time. This is a very tried and true pulse eddy currents have been around for many, many years. So PAC is what our robot uses today. There's a secondary inspection methodology called real-time radiography, basically X-rays, and another scanning tool that worked through insulation. And we have a development project underway to have a real-time radiography probe on our Venus robot as well. So, the next 12 months, we'll have PAC robot, which is fully available today, works great, and then a real-time radiography. Some customers, it's a customer preference. You can get similar but a little bit different data from each methodology. Some customers prefer PAC, some customers prefer radiography, some customers like to use both at the same time or in conjunction with each other.
Can the inspections be conducted while the plant is in operation, or does it require a shutdown or a slowdown?
No, this is really one of the great things about what we do is that, in fact, it's almost always done while the plant is in full operation. It's safe to use while the plant is operating, and often this is used before, in advance of what asset owners call turnaround, which is a maintenance period where they go in and so they'd want to know where all the corrosion is on their piping. So during that maintenance period of that turnaround, then they can go in and do all the pipe stripping. So I think that a lot of times they do the inspections while the plant is running and then fix it during their turnaround. So almost always our robots are running during full operations with whatever material is going through those piping is going through it.
Are the environments your robot works in chemically harsh or hazardous? How does that influence the design?
They certainly can be from a couple of different areas. One is just, what's the ambient temperature of the environment? We've run these in, Canada, northern Canada in the winter, and we've run them in Saudi Arabia in the summer. And so just the environmental conditions. And then you need to take account, is it misting? Is it icy? Is there dust blowing? So they're, very sensitive electromechanical devices. And, if you're in Saudi Arabia and you've got a sandstorm and there's, grit blowing into your wheels or into the vents or into the electronics, that can cause a real problem. And, obviously in the 8 years of development and testing, we've come across a lot of issues that we've had to solve and overcome. But our current version of robot, operates very well in harsh environments. Additionally, sometimes the material that's traveling through the pipe is very, very hot and can be 100 degrees C, kind of on the pipe surface. And so we need to be able to manage that as well. The robot is, there's titanium and carbon fiber and, all kinds of exotic materials that make it very, very strong and very, very tolerant of harsh environments.
It took 8 years to develop the robot. What were some of the most important lessons learned during that process?
I wasn't here for all of that. I'm a relatively new addition to the team as the CEO. But I remember some of the things that we came across or that I've heard was having enough clamping force to keep the robot on the pipe and not slip so you know where it is versus deforming the pipe. If you were to walk up to one of these pipes that has carbon steel and insulation and this thin aluminum jacket, it deflects a little bit. You can squish it with your hands. And the asset owners, don't want a heavy over clamping pipe to deform their piping. And then there's various forms of, not all of them have a more firm aluminum jacket on it. Some of it is more of a plastic. It's much softer. So we need to be able to operate across all of those things and then have enough clamping force to go up to have a 20-pound robot with a 100-foot umbilical cord go up 100 feet in the air while staying, 100% certainty of staying on the pipe and not falling and while not deforming it. So there's just lots of lessons learned around that. I think, at one point we tried to have a robot that did everything, that went around all the elbows. And, we are our great roboticists here. We developed a product and actually released it and would go around elbows. But it turned out we needed too much clearance so that it wouldn't go into the pipe racks. So like any product development, there's all these design trade-offs. And it really took 8 years of development to get to what we'd call product market fit. We're really starting to get good traction. It's a great founder story. The company was founded by a woman named Diana Liu, who grew up in Texas, went to Duke as an engineer, then worked at ExxonMobil. And one of her management rotations at ExxonMobil was in the inspection group and realized, well, there's got to be a better way to do this. And then went off to get an MBA at Yale. And this is part of her entrepreneurship project. She actually started the company while she was at Yale and hired a couple of Yale undergrad mechanical engineers to work on this project with her. And then they all moved to Houston together. And we're, grinding away on this for 8 years with all these various iterations of the robot to find the the perfect blend of some of the characteristics that I just talked about. Venture capital funded, and then I was brought in January to help scale the business. But it's just a great founder story of perseverance and kind of in search of never giving up.
What drew you personally to Arix, and what excited you about taking the CEO role?
Yeah, I've spent the last 30 years as the founder and CEO of a number of growth stage companies. Most of all venture capital funded, all in the hardware, software, kind of SaaS space. I really enjoy early stage companies, is what I've spent my career doing. And what attracted me about Arix was really a couple of things. One is that, and I do not have an oil and gas background. A lot of my career was in the enterprise communication space. I did have a 4-year stint in another part of the field in robotics, so I'm kind of familiar with all of this, other than the oil and gas customer and use case. But what attracted me to the company is it was obvious that it solved a huge problem. It was a compelling value proposition for customers. Huge value proposition for customers. Solved a giant problem for them. Secondly, the company has demonstrated there's real product market fit, which is incredibly important in terms of the ability to start to scale revenue. So it was obvious the company was ready to scale revenue. There's a deep moat of defensible intellectual property, and I know that sounds like a very technical term, but in terms of building a business that has value and competitive barriers, this moat of intellectual property, and it's not just around patents, it's around 8 years of know-how. So that's an important thing in any technology company, to kind of give yourself time to establish a brand without 12 competitors jumping in and at a lower price. In terms of the what we would call the unit economics of the business, it's very attractive to what we can charge because of the value provide versus what it costs the robot. So it gives us the ability to build a scalable, cash efficient business. And then the last one is it's a huge market. I mean, the oil and gas market is I think the largest industry in the world, trillions and trillions of dollars. And a lot of that is, we spend a lot of time in downstream and research. We've seen studies that half the maintenance budget of a refinery goes to trying to ferret out corrosion because of all these refineries self-insure and can cause catastrophic incidents if they're not. So lots of things to like about this business that really aren't specific to oil and gas, but are just specific to building a technology company that's got legs.
Looking ahead, how do you see ground robots and aerial drones working together to offer a more complete inspection solution?
Yes, this is my second stint in a robotics company. My last company, we were taking electric forklift trucks and turning them into autonomous vehicles for use in warehouses. So that was pretty cool. And what I realized there is that in all kind of industrial applications, we're at the very, very front end of this inevitable shift to automation across so many different types of industrial applications. And there's going to be multiple ways, multiple different types of platforms that work together to solve the full scope of inspections in refineries. Our pipe crawling robot isn't going to solve everything, just like a flying drone. And over the next 10 years, there's going to be industry consolidation where ground-based robots are acquired into companies that are building flying robots with a common operating system and platform that work in conjunction with each other depending on the flow. I think it's again, we're just at the very, very, just scratching the surface of what's possible here, in terms of how these devices can work together from a single control panel and a single architecture. And maybe most importantly for the customer, a single source of truth for the data, where they can see, in a single pane of glass, where are my corrosion problems, rather than I got this vendor that does radiography inspection on tanks with a robot. I've got these other pigging robots that go inside the pipes. I've got these other exoskeletons that go on the outside of the pipes. I think we'll all start to come together in a more consolidated sort of platform.
Does your robot or the system incorporate artificial intelligence today?
It does, particularly around the real-time radiography. The way that's done today is an operator basically stares at the screen, almost a video screen, looking at this real-time image. And then if they see with their own eyes some area where there's, that indicates corrosion, they mark it. With our robotic system, we're scanning so much pipe down and then rotate and then back. We actually use some AI technology in terms of the optical recognition, training the robot and the software to see what that corrosion is. So you're able to find it much more rapidly and much more exactly and much more reliably than a human doing it. So that's one example of where we're using some AI tools and some machine learning tools to make the inspections better and more reliable and faster.
When you talk to new clients, what type of ROI can they expect, whether in terms of time, cost savings, or operational efficiency?
Each customer is a little bit different depending on what their, how they do it, what their inspection budget is, how often they inspect, how much of their piping they inspect. Some of the data that's been pretty consistent so far is that we are 10 times faster, and we can inspect 10 times the piping that you can do manually, and we inspect it at 100% versus very, very small percentage. And it's about a 75% savings versus stripping all the piping, stripping the insulation on the piping, or building huge amounts of scaffolding, for people to walk on and do the manual inspection. So it's really a dramatic improvement in time, in cost, in comprehensive inspection, which results in reduction of risk and safety.
What's next for Arix? What milestones can we look forward to in the coming months?
Well, I think we just announced a partner program. So today we primarily service our customers through direct inspection. We have crews, a 2-person crew that goes out with our robot and does the pipe inspection. But we're a relatively small company and don't have customer relationships with many hundreds of refineries and customer locations around the world. And often a great way to scale a business is through partnerships and channel partnerships and resellers. So we just announced a partnership program to work with third-party inspection companies who often buy drones or other types of operate robotic equipment. Many of those large inspection companies that are global, that are multi-billion-dollar publicly traded companies, maybe they started out in manual inspections many years ago and are starting to integrate robotic inspections. So new program to establish that'll be great for us, certainly outside the United States. And then we're continuing to product development, continuing to make our products faster, better, less expensive, do more, with different types of inspection methodologies, but really focus on this CUI problem for piping. It just is a huge, really intractable problem in the industry, and we've got a lot of room there to run.
Is there anything that we missed that we should talk about?
Well, again, I think just like reiterate, this is the very front end of this inevitable transition to automation. And at Arix, we've developed, I think, a really unique solution for customers to improve safety and save money at their sites.
And for my final question, Craig, what message would you like to leave regarding the future of the drone industry?
Drones are really, really interesting because they have applicability across all types of everything, just from, as a replacement for fireworks, in shows for, 4th of July. And being a former military officer, obviously, I'm very interested in how drones are completely reinventing warfare. I mean, it's unbelievable what the world is going to look like in 25 to 30 years just because of aerial drone technology. And that's not even taking into account, the more mundane but important task of, inspecting tanks and pipes at oil refineries. So drones are super cool. But again, robotics, kind of our ground-based robotics, are going to play an important part in that as well. I'm excited to be a part of Arix here.
That's it for episode 443 of the Drone Radio Show. I hope you enjoyed hearing from Craig Malloy of Arix Technologies. I want to thank Craig for taking the time to speak with me. If you want to learn more about Arix Technologies or want to connect with Craig, check out the webpage at arix-tech.com, and Arix is spelled A-R-I-X. If you like the Drone Radio Show, then please subscribe and share. Write a glowing review on your favorite platform. And if you're able, donate to keep the podcast going. Go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.